Hey guys, welcome to the OneClass channel. My name is Cindy and I'm currently a third-year engineering student. Today we'll be going over some commonly asked math questions at both the high school and university level. If you need some additional homework help or tutoring, please check out the links in the description below. Okay, let's get started. Alright, so the first question that we have today is asking how to rewrite 1.05 with the 0.05 repeating as an equivalent fraction of integers. So first we have x is equal to 1.05, and they said that this 0.05 is repeating, so usually they write it with the notation of a bar or line above the repeating decimals. And our goal here is to convert this into a fraction of integers. So the first thing that we can do is multiply this by 100. So multiplying both sides by 100, we have 100x is equal to 105.05 since, well, the 1.05 with the 0.05 repeating is kind of like this, in the long form. So when you move the decimal twice to multiply by 100, you still have the repeating decimal at the end. So it's still 0.05 repeating. Okay, and then now that we have this statement, what we can do is subtract the original equation for x here, okay? So we're subtracting x equals to 1.05 repeating so that we can get rid of this repeating decimal here, because every single one, like I said before, this is what it looks like when it's expanded. Every single one of those decimals will line up and cancel each other out, okay? So when we subtract the whole equation from the previous one here, we get 99x is equal to 104, right? And then all we have to do is rearrange. We have 104 divided by 99, just by dividing both sides by 99, and that is your integer, okay? Those are two whole numbers, or integers, and you can't reduce this fraction any further, so that is the answer to this question. Alright, so they have the same solution here, and I'm just going to write correct. Oops, good work. And we can go to the next question. Okay, the second question is asking, what is a quotient? So a quotient is the answer to any division problem. So, and it says here that a division problem describes how many times a number can be subtracted from another number. So here it gives the example that 36 divided by 9 is equal to 4, and it shows that 36 is the dividend, 9 is the divisor, and therefore 4 is the quotient. So that is the answer to the division problem. And it also tells us that 9 can go into 46 4 whole times. okay? And the way that they showed it here was by subtracting 9 from 36, and we'll see how many times we can subtract it from 36 until we get 0, okay? So we have 36 minus 9, that's 27. So then we go again. Sorry, that might be confusing. We go again, we have 27 minus 9, and now we know that's 18. Once we have 18, subtract 9 again, and we get 9. And then the final time, 9 minus 9, we have 0. So that 9 can be subtracted from 36 1 time, 2 times, 3 times, and 4 times. So that's why, therefore, we have 36 divided by 9 is equal to 4, where 4 is the quotient for this problem. Okay, so that's the solution. We got the same answer. Let's say next solution. Good work. Okay, on to the third question. So this question is asking us, what is the formula of the surface area of a cylinder? All right, question number 3. So we're looking for the surface area of a cylinder. So let's draw a cylinder here. We have, oops, it's not very nice. We have the base here. So this is the top. We have base, and we have what I'm going to call the lateral surface of the cylinder. So that's basically, well, if you're imagining this as like a tube or a pipe or a dowel or something like that, like a paper towel roll, the lateral surface would be the exterior surface area. But because it's a cylinder, we also have the top and bottom. All right, and this has a radius of r. In this example, they use lowercase, so I'm going to do that too. And the cylinder has a height h, right? So yeah, I'm just going to write that here so it's clear. R is the radius, and h is the height. And we're going to split this up into 2 different sections. We're going to say that, surface area of a cylinder is equal to the area of the top plus the area of the base plus the area of the lateral surface. But since we see that the top and the base are the same, the same circle, we're going to group these together, and we're just going to say 2 times the area of the base plus the lateral area. Okay, so now we need to figure out exactly what the area of the base is and what the area of the lateral surface is. All right, so let's start with the base. So if we were to imagine this, we can see that the base and the top surface of the cylinder, they're just circles. So it's not a very nice circle, but you get the idea. That circle has a radius r, as we stated up above here. All right, and so that means that the area of the base and the area of the top is just equal to the area of a circle. And we know that the area of a circle is pi r squared. Okay, so now that we have the area of the base, which is equal to the area of the top of the cylinder, we need to find the area of the lateral surface. Just to be clear, surface. Okay, so the lateral surface of the cylinder is the whole outside, say like of a tube or something like that, right? So it's not including the top and the base, since we already did that. You can kind of imagine it. So this hollow tube, if we had, say, the toilet paper roll or the paper towel roll, and you sliced it down one side and you unrolled it, you would see that you would just have a large rectangle, okay? And this rectangle, since the cylinder had a height of h, the rectangle would also have a height of h. But in order to find out what the surface area is of this rectangle, we also need to know the length, right? I'll just write here the area of the lateral section, the lateral surface is equal to the area of a rectangle, which we see in the drawing. And we know that the area of a rectangle is just length times width. So yeah, like I was saying, we need to figure out what this length is. So that length, this length here, is the same thing as the circumference, right? Because if you're imagining you had your tube and you unrolled it, it would trace the same path as the circumference. We know the circumference of a circle. I'm going to write here, circumference of a circle, that is equal to 2 pi r, right? So if that's the length and this is the width, then we can fill that in. There we go. 2 pi r times the height, and that is the area of the lateral surface. So now all we have to do is go back up here and sub everything we just found out into that equation we came up with before. So therefore we have the area of a cylinder is equal to 2 times, oops, I'll just write what we had before down here so it's easier to see all together. So 2 times the base, the area of the base, plus the area of the lateral surface. And we found out that the area of the base is the same as the area of a circle, so that's pi r squared right here. Pi r squared plus the area of the lateral surface, which we found out to be 2 pi r h. Okay. Now that we have this, all we have to do really is simplify. You can take out a 2, take out a pi, and take out an r, and you get r plus h. So we can say that the area is this. You obviously don't have to factor out the 2 pi r, but if you want to, this simplifies the formula just a little bit. So the surface area of a cylinder is 2 pi r times r plus h, where, remember, r is the radius and h is the height. All right, that's that for that question. And let's double check. And that's what they got here. Simplified version. All right, sounds good. That's correct. And we can go on to the next question. Okay, so this is question number 4. So the question here is asking, well, it's giving us an equation. We have 9x plus 9y equals 2. And it's asking, first of all, find the derivative of y by implicit differentiation. And then it's asking us to solve the equation explicitly for y and differentiate to get the first derivative of y in terms of x. And then it's asking to compare the solutions from A and B to make sure that they are consistent. So first we're going to perform implicit differentiation. Differentiation. Okay. So when we're applying implicit differentiation, we don't have to rearrange or anything. We can just take the derivative as is. So let's do that. I'm going to take the derivative of both sides. Derivative of 2. Okay. So let's start. So the derivative of 9x is just 9, plus the derivative of 9y is 9, but because you're taking the derivative of y, you have to write dy by dx, since, well, this one is just 9 because we're taking the derivative of x here, right? So because it's y and it's implicit differentiation, we have to sort of signal that we're taking the derivative of y by adding in this dy by dx term. And then just the derivative of 2, well, 2 is a constant, so that is 0. Okay, so it did ask for y prime or dy by dx. dy by dx and y prime are, I'll just rewrite it in that notation. They're equivalent, so they mean the same thing. So that means we just have to rearrange. So we have 9 y prime equals to minus 9. Therefore, y, if you divide both sides by 9, you get minus 1. So that's the answer for the first derivative of y using implicit differentiation. So going to B, it's asking to solve it explicitly now. So I'll write that. We need to perform explicit differentiation. And really the only difference is that we are going to rearrange first. So this is probably the way you normally perform differentiation if you have a linear. So let's do that. We'll rearrange for y first. Okay? So we have, this is our original equation, remember? So we have 9y equals to minus 9x, and divide both sides by 9, 2 minus 9x divided by 9, and this is what we get. And now, well, I'm just going to simplify this a little bit more. We have we're just going to split this fraction into 2 different terms. So 2, and then it's 2 divided by 9 minus 9 divided by 9x, and 9 divided by 9 is just 1. So I'm just going to write minus x. Okay, so now it's a little bit easier, and we're going to take the derivative of this, okay? So dy by dx, and the derivative of here, let me write it out. So it's clear. We have the derivative of 2 divided by 9 minus x. We can perform it on each term separately. So the derivative of 2 divided by 9 is 0. And the derivative of minus x is, it's moving away, is minus 1. Okay, so this gives the answer that, well, dy by dx is equal to minus 1. And remember, dy by dx is the same thing as saying y prime. So that is our answer. And if we compare, we see that we get the same thing. We've got the same thing by doing both methods, solving it both implicitly and explicitly. So part C is just asking us to compare the solutions to make sure that they're consistent. It suggests subbing in this equation for y into well, I guess just into the derivative of y. So that would be sort of like this. Remember we had dy by dx is equal to minus 1, just right here, right? And we also said that y is equal to 2. 2 divided by 9 minus x. And so if we just sub the y in here, we can easily see that we'll get the exact same thing. Minus 1. And yeah, so we see that we get minus 1 on both sides, meaning that this solution was correct. And it might seem silly that I'm doing this because I took both things from this second part here, but we also found that dy by dx is equal to minus 1 in the first equation. Anyways, it's pretty redundant, but that is what they're looking for in the question, just to confirm that both answers from A and B are the same. So yeah, they both give us -1. And that's all for that question. It just states here in C that since they both give the same answer of -1, therefore the derivative with respect to x can be obtained by both explicit and implicit differentiation. So just confirming what we said before. So good work. That's correct. Okay. All right, so this question asks us what is the point slope form. This is question 5. So it says here that a linear equation or linear equations can give us a way to relate two things together. Misspelled, but two things together. So they give the example here that the number of calories you consume for every cookie that you eat, or the number of steps that you take to travel a certain distance, are linearly related relationships because their values depend on each other proportionally. So the change in of the first variable will always have a constant effect on the second variable. So yeah, I think those are kind of confusing examples, but hopefully we can see as we go through the example. So basically the point slope form is just a way of writing an equation of a line. So I'm just going to draw a line So we have a plot of y to x, or x to y. And if I just have a linear line, it just basically means a line with no slope, or sorry, obviously the line has slope, a line with no curves. It's just straight. We see that it goes from y1 to y2, and from x1 to x2. So this point is y1. Oops, sorry. X goes first. x1, y1 to x2, y2. All right. So if we want to find the equation of the line, one way we can do it is, by using the slope, the point slope form. Okay. So this slope we like to call m. Equals to m. Slope is equal to m, and that can be measured by, well, let's make this bigger. So that can be measured by figuring out what the difference is between x2, hold on, we have y first actually. Here, if we go this way, we want to know what y2 minus y1 is to travel vertically that far, and in order to travel horizontally that far, we need to know what the difference between x2 and x1 are. Might be a little bit of a confusing way of explaining that. If you've seen this before, it's probably already pretty obvious to you that this is what the point slope form looks like. You can also rearrange it, of course. 2 minus x1 is equal to y2 minus y1, or sometimes you could generalize this. I'm just going to write in general. Oops, that doesn't look like anything. General, we have x minus x naught, where x naught is the initial x. So if you write this is x naught instead, and this is just x, right? You might see it in this way. That's the only reason why I would include it. But if you are not familiar with x naught or y naught, then just you'll probably just use the 1 and 2 notations instead. All right, so that's pretty much it for the point slope form. Let's look at the answer, and we have the same two equations here. I just swapped the order of them, so just flipped what's on the left and on the right, and they also give the general form here. So we can say that the solution is correct. Good work. And move on to the next question. Okay, our last question for today is asking what the product rule for differentiation is. So this is question 6. So product rule for differentiation. So first, in the solution, it gives you a function. I'm going to write function v of x. All right, and v of x is made up of two separate functions. We have f of x times g of x. All right, so if we want to take the derivative of this function, this would be a notation of the derivative of the function, right? We're trying to figure out how to take the derivative of these two terms when they are multiplied by each other. That is considered the product rule, okay? So when we're taking the derivative of v of x, we need to take the derivative of f of x, derivative of f of x times g of x plus f of x, so that's just as it is, times the derivative of g of x. Oops. Okay, so this g of x in the first term here, we have one derivative, this one's a derivative of f of x, and this one, g of x, is just the same as it was given in the equation. And so the second term here, you leave the first one as is and take the derivative of the second one. So we're kind of taking turns, which one's the derivative, or which one you're taking the derivative of, and which one is staying the same. You might have also seen this product rule shown in a different way. This is the way that I've seen it before. Usually it's written as u times v. So if, we want to take the derivative of two functions that are multiplying each other, just like we said up above here. In this case, instead of f of x and g of x, it's just u and v. You have u. How about I'll go in the same order that I did above. So you have the derivative of the first term, this term here, times the second term as it is, plus the first term, u as it is, times the derivative of the second term. So these two lines here are just saying the same thing. I just wanted to write it in two different ways in case you've seen one or the other before. And let's go through an example so we can apply this. So this example gives a v of x as 2x plus 1 times 3x squared. And if we want to take the derivative of this, so we have the v of x. Just so you know, I switched the notation here. And I just want to make it clear that this is the same thing as saying d of v by dx using the prime notation. These both, there we go. These two both are just saying the derivative of v, of the function v, okay? So just to be clear, the notation means the same thing. So yeah, derivative of that side, then we have to take the derivative of the other side. I'll go, okay, write it all out so that we can see this step. 3x squared. Okay, so now we're taking the derivative of both sides. So remember, this notation just means the same thing. Okay, so let's take the derivative using the product rule, okay? So remember, the product rule states that you take the derivative of the first term. So in this case, I'm taking the derivative of 2x plus 1 first, okay? So the derivative of 2x plus 1 is just 2, because remember, 1 is a constant, so that would give 0. So you can just say 2. And then we, how about I write it out like this first, so that it's the same as what we've seen before. So I'll put it in square brackets so you can tell that this is what we're taking the derivative of, and then the 3x squared stays the same, and then add that to the 2x plus 1 times the derivative of the second term, which is 3x squared. So I just wanted to rewrite that so that we simulated what we did before up here, right? Just replacing the u and the v with the two terms in this equation here. Hopefully that's clear. And now we are ready to take the derivative. You can obviously skip steps if this makes sense to you. So we get 2, that's the derivative of 2x plus 1. And remember, we just have 3x squared stay the same. So plus the next term, we have 2x squared plus 1 stays the same, times the derivative of 3x squared. Derivative of 3x squared is 6x. Remember, using the power rule, we distribute, or we multiply 3 times 2, 3 times the exponent, which would give you 6. Oops. And then subtract 1 from the exponent. So instead of to the power of 2, it's now to the power of 1. All right, we can expand this a little bit. So we have 2 times 3 squared is 6x squared plus, and then let's distribute this into the bracket. We have plus 2x times 6x, which is 12x squared, plus 1 times 6x, which is just 6x. Okay, we can combine these terms. So we have 18x squared plus 6x. And that can be our final answer for the derivative of b. You don't really have to factor if you don't want to. You could do something like this. However, I don't think it's necessary for this question. It depends on what you're doing. But if you want to, that would be the answer. And yeah, so that is the application of the product rule. So let's look what they wrote here. And we got the same answer. So that's correct. Good work. Okay. So that's all we're going to be covering today. If you did find this helpful, please leave a like, and if you want to be notified of when we do another Q&A like this, please hit the subscribe button and the notification bell so you can be notified when that happens. If you want to submit any of your own questions, you can see the links down in the description below or leave a comment, and that's all for today. Thanks for